This video is going to look at some other laws of logs or little corollaries that could be used to help us evaluate logs a little faster. Now these are given here in this box, however they're not stated on our formula sheet. So it's something that in the past students have either memorized or through a combination of other laws just could work their way through without having to actually memorize all of these. So we're going to work through these examples and we're going to use those laws on the side or maybe some common sense to figure out what's going on here. So the first one says evaluate log base 3x of 3x. Now remember, the answer to a log is always an exponent. So this is basically saying what power of 3x would get me 3x. The answer to this, log base 3x of 3x, is 1. And the way it's explained here is an example, or the other law, 3, any log that has the same base as its stuff is always equaled to 1. So that's explained in that little log here, or law. Evaluate log 3x equaling 0. Now this is saying what power of 3x would get me an answer of 0. So you can search through all of your brain and try to figure out what's going on here. But if you look at the example or the other law 1, it's saying if I have any law or any log that has base a of any old stuff, it's undefined when x is less than or equal to 0. So if this stuff is negative or 0, this is undefined. This case here, since it's 0, there is no exponent that I could put on 3x that would ever give me an answer of 0. The next example 3 is saying evaluate log 3x of 1. So again, we've talked about the answer to a log always being an exponent. This is saying what power of 3x gets me to 1. Back from when you first started learning about exponents in grade 9 and 10, we really pushed the fact that anything to the power of 0 is 1. So this simply is log base 3x of 1 equals 0, because 3x to the power of 0 would equal 1. And we can see right here, the law number 2, any log with any base that has the stuff being 1 is always an answer of 0, because anything to the power of 0 would have to give you 1. The next example, 4, goes and says evaluate log base 3x of negative 3. Examining this, we're trying to ask ourselves what power of 3x would get us an answer of negative 3? Well, nothing would. This is undefined, and again, if we look up at the first other law, anytime that stuff is negative or equal to 0, we don't have an answer for this log expression or equation, so we just call it undefined. The next one, example 5, you can think yourself through this one. We'll show different ways of doing it. We looked at these earlier on in this unit. We said evaluate log base 3 of 3 to the power of 4. So what power of 3 equals 3 to the power of 4? Well, we know the answer has to be 4. Another way to look at it, tying in the power law that we've looked at, is to say we can bring this 4 down in front. So I had 4 log base 3 of 3, and if I look at the log expression, 3 to the power of what gets me 3? Well, the answer is 1, so this turns out to be 4 times 1, which equals 4, a different way to look at it. And then up here in the other laws, it showed that if you have log of any base a, but your stuff has the same base, and it's raised to an exponent, the answer is simply the exponent. So as you can see, some of these laws that are considered other laws of logs are pretty self-explanatory. You can work your way around them, but some kids like to memorize them. I wouldn't suggest doing that, but it's good to just look at some of these questions and try to figure your way through them. The next question, example 6, is saying evaluate log base x minus 1 of x minus 1 squared. This is the exact same question as example 5 above it, except with polynomials. We know that this answer could be 2 if you think of it as the answer to a log being an exponent, x minus 1 to the exponent of 2 has to equal x minus 1 exponent 2. Or we can use the power law again and say log, bring that power, that 2 down. So 2 times the log of x minus 1 of x minus 1. This expression here simply equals 1. So 2 times 1 still gets me to 2. And away we go. The next one, evaluate 3 to the power of log base 3 of x. Now there's one of these laws up here, number 4, that says if I ever have a power, so a base of a, but my power is, my exponent is a log with the same base, the whole answer to this is simply the stuff of that power. So if I look back here and apply that other law, number 4, I'm seeing I have a base 3, my exponent's a log with a base 3, this whole thing simply equals x. Carrying this logic forward to the next example, we have the situation where I have a 4 out front, but now I have a power that has a base 2 and an exponent with a log base 2 of 6. So this whole chunk here simply equals 6, multiplying that by 4. The whole expression is 24. Looking at example 9 now, we see that it's saying, you know what, let's simplify this expression. I have log base 5 of 25 to the power of k. We got to think through all of the laws we've looked at so far. The first law, and I'll just rewrite this, that I would consider is I have stuff with an exponent on it, so I might as well drop that k out front. So I'd have k log 5 of 25. Now logic should kick in and realize that the base of this log and its stuff are related by a power. We could say 5 to the power of 2 gets me 25. So this whole expression equals 2. And we're still multiplying by k. So now to put this into proper notation, the answer would simply be 2k. Now if you couldn't right here just pick up that this answer was 2, remember we did learn change of base for logs, so I could take log base 5 of 25, and if I needed to use my calculator to help me, I can change that into base 10 and say that's log base 25 over log base 5. And if you were to crunch that in your calculator, you still would get a 2. So if you're having just one of those moments where you're a little stressed and you just aren't seeing that log base 5 of 25 is 2, use your change of base and do the question. Last example here has us simplifying the expression log base a of the square root of a raised to the x. It says write this down in simpler form. So first thing I would consider is that I have my stuff with the power of x, so I'd be dropping that x down. So I'd be saying x log a of the square root of a. Now looking back into grade 10 and 11 on our radicals units and radicals with their exponents, I know that the root of a is the same thing as a to the 1/2. So I can rewrite this log expression as log base a of a to the 1/2, still with that x out front. Now if I examine this again, I do have a power of a half on that a, which means I could take this half and drop it yet again. So I'd have half an x is multiplied by log base a of a. This here, from either the other laws up above or from some common sense saying what power of a gets me a, this whole thing equals 1. And if I'm multiplying that by half an x, my whole answer could be 1/2 x. Or we could simplify that a bit if we wanted to and say that's just x over 2. Both of them are acceptable answers, but all I'm saying is that this whole thing simplifies to x over 2. Now you can see you have to do some thinking on a lot of these questions. You can refer to these other laws. You can usually get around just using common sense and some of the other log laws we've examined in the past. So now I'd ask you to look at the questions on the next page, work through them, and if you need answers, go to puremath30.com and look up this lesson.